Good morning, everyone. We are on Module 6 of Chapter 12 Sound. Today, we are going to discuss about pitch and loudness of sound. The pitch of sound depends on the frequency of vibration. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. Short wavelength means lots of waves. High frequency, high sound. Long wavelength means fewer waves. Low frequency, low sound. Since the sounds are traveling at about the same speed, the one with the shorter wavelength will go by more frequently. It has a higher frequency or pitch. In other words, it sounds higher. The loudness of sound depends upon the amplitude of vibration. If the amplitude is bigger, the sound is loud, and if the amplitude is smaller, the sound is soft. The size of a wave, how much it is piled up at the high points, is its amplitude. For sound waves, the bigger the amplitude, the louder the sound. The speed of sound is different in different media. The speed of sound is more in solid, less in liquids, and least in gases. The speed of sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of sound is more. Relationship between speed, frequency, and wavelength. Speed equal to wavelength into frequency. Speed is denoted by the letter V. Wavelength is denoted by the Greek letter lambda, and frequency is denoted by nu. There are a chart given in which speed of sound in different media at 25 degrees Celsius. Solid aluminium, that is 6420 meter per second, steel 5960, iron 5950, glass 3980. If you talk about liquids, in seawater, the speed of sound is 1531. In distilled water, it is 1498. Ethanol 1207. And if we talk about gases, hydrogen 1284, oxygen 316. So you can come to know about sound is more in solids, less in liquids, and least in gases. If we talk about laws of reflection of sound, like light, sound gets reflected at the surface of a liquid or solid and follows the laws of reflection. The angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and normal at the point of the incidence all lie in the same plane. Take two pipes of the same length and arrange them on a table near a wall or metal plate. Keep a clock near the open end of one pipe and try to hear the sound of the clock through the other pipe by adjusting the position of the pipe. Now measure the angles of incidence and reflection. Then lift the sound pipe and try to hear the sound. It will be seen that the angle of incidence is equal to the angle of reflection. The incident ray, reflected ray, and normal all lie in the same plane. There is a diagram that is shown here, reflection of sound from the plane surface. So you can see screen is at 90 degree and it is normal, and the angle formed with the normal with the incident ray is angle of incidence, and this is angle of incidence is equal to the angle of reflection. Thank you.